Good afternoon. I want to start off by describing what, to me, was a very hesitant entry into this field of practicing compassion. And it was hesitant because I started with the recognition that people who try to practice compassion often end up failing because either their compassion is taken advantage of, their pockets get picked, they repeatedly fail, they turn bitter, they have a sense of failure and almost a sense of saying, forget it, it's not worth it, let me do what I can and look inwards. So stepping back, I realized from watching my own thesis advisor, Art Rosenfeld, that it doesn't have to be so. So long as you are shrewd and not gullible, you can be compassionate rather than self-centered. So being shrewd and gullible is orthogonal to being compassionate versus self-centered. So you want to be shrewd and compassionate and not a jerk. So that was the first kind of realization. And that got me engaged in trying to do what I could to address problems at the bottom of the economic pyramid with technological innovation implemented in a way that was smart, which was going to actually go to scale in engineering science. Going to scale means not helping just a dozen or 100 or 1,000 people, but aiming to help at least 1 million or 10 million people. Then we are talking some sense in terms of making a worldwide impact. So I started, spurred by an outbreak of cholera in India in 1993, to begin to worry seriously about lack of safe drinking water. So about 2 billion people in the world don't have access to safe drinking water. And these young women in Ghana are carrying their daily family supply of safe, I shouldn't say safe, but as clear as they could get, drinking water on their heads. They'll make several trips during the day. And the reason they're walking in the muddy water is because they try to go in the deeper water to try to get slightly clearer, slightly less turbid water supply, and that's going to be their drinking water. The reason they cannot boil their water to disinfect it is because boiling takes so much fuel, 3 times more fuel than the fuel they use for cooking, that boiling is really not an option. So this outbreak of cholera forced me to think about what could be done to try to address the problem in a way that is robust, that will work in the back of beyond in the rural environment in developing countries, that will be inexpensive enough that they can afford it. At the same time, there should be no compromise on the quality of disinfected water. When I was in Dhaka, in Bangladesh, in December 2009, here is a photograph from their cholera hospital. The entire ward is filled with cholera people on drip, and they are the ones who will survive. The people who don't survive with cholera or diarrheal diseases or dehydration are mostly children below age 5. And we currently lose 2 million people to diarrheal deaths from waterborne disease. So that is 200 per hour. And the goal all along is to try to figure out what can be done, not just in the laboratory, but something that can be taken to scale out into the real world. So I and my team developed an invention that is now gone to scale with a US company that works exclusively in the developing world. And this slide here shows you a photograph of this installation in the village of Pokuase in Ghana. People can buy water at a price of 0.2 US cent per liter. And this water meets or exceeds WHO and US EPA requirements for bacterial contamination. The point is, having done stuff like this, students asked me from Berkeley, can you teach a course about this? These were students in engineering, students from the Berkeley chapter of Engineers for a Sustainable World. I'd never done anything like this, so I worked with them to try to figure out what should that course be like, what would we teach in a way that allows them or enables them to express their compassion in a way that doesn't lead to cynicism or a sense of failure. So the structure of the course, it's a graduate course because you don't want to start teaching them F equal to MA. You want them to come in knowing their engineering. But they also want to understand political economy. They need to understand sociology. They need to understand consumer behavior. They need to understand how businesses work. They need to understand a whole lot of stuff that is outside of engineering. So it turns out that the course, finally, the way it took shape, is about 2/3 of the course is non-engineering stuff, still about the real world, but it's about the stuff that I mentioned to you a moment ago. And 1/3 of it is about engineering and innovation. A lot of case studies of what has failed, because the developing countries are a museum of failed projects. 100 projects fail for one project that succeeds. And my goal is to empower these students to go out and be the one and not the 100 when they increment the number of projects that are tried. So just as an example, the kind of projects that this course has done, on the right-hand side, you see an extremely low-cost solar water heater being tried out in Guatemala. And on the left-hand side, you see a house that is designed for low-income housing in Southern Pacific on islands where everything has to be imported. So the idea where you don't want air conditioning, it's hot and humid, and you want a design that is naturally cool. Here on the left-hand side, you see a student from the course testing for arsenic contamination in Bangladesh village. Bangladesh has what is rightly called the largest case of mass poisoning in the history of mankind, with 70 million people exposed to extraordinarily high levels of arsenic. And this project has led to now additional inventions that actually are able to fix the problem of arsenic at a price that is affordable locally, that is technically robust and meets WHO limits. And we haven't gotten it rolled out into scale yet, but I'll tell you a story about a scale in a second. On the right-hand side of the figure, you see a device that makes coir board for local places in, again, Southern Pacific, where you don't want to import plywood from France. On the left-hand side here in the figure, you see a village in Gujarat, in India, where people are trying to figure out how to provide better lighting for fishermen village, which are itinerant because they move in and out of the coastal regions as it gets flooded. They have no permanent homes, no schooling, and they use kerosene lighting, and they spend most of their income on buying kerosene. So there's a lighting project. On the right-hand side, you see a woman and a little baby in a Darfur camp. 80% of the occupants of the camps are women and girls, because mostly men have been killed. And the reason we got involved in the project is because I got a call from USAID saying, what can you do to help these people as they get systematically attacked and raped and mutilated when they must leave the safety of their camps to collect fieldwood, because United Nations can only give them food but not the fuel, and they must leave the safety of the camps. So we designed a stove in collaboration with the women, which is, and you see a photograph here of a factory that actually now is set up in Darfur, where they build the stoves that we designed. And the stoves save them about half of the fuel that they used, which saves them about 1 or 2 trips a week. Instead of taking 3 trips, now they can take 1.5 trips on the average to collect fieldwood or sell. Currently, they sell their food to buy wood, and now they sell less food, so they are less hungry as a result. We went back too far. Hang on. OK. So in summary, what I learned from the course is that the supply of educational opportunities for frustrated engineering graduate students to turn their compassion into an impact on the real world, that supply is vastly less than the demand. There are courses like the one I described at MIT called the D-Lab, at Stanford called Design for Extreme Affordability. But overall, in the United States, is nothing compared to what the demand is. And that's because engineering education has been stovepiped into narrow disciplines and doesn't address real-world problems that require interdisciplinary work. Second thing I learned from the course is the students work extraordinarily hard and are empowered when they get to see how much they don't know and how much they need to know and how much they can do if they work along with sociologists and economists and architects and business students, so that the teamwork that brings them together truly empowers them and energizes them to the point that they do 6 units coursework for a 3-unit course. So this is something which blows me away every time I teach a course, to see how much power is released in terms of the energy that they bring to the table. So there is lots that we can do. There is just a little bit of scratching the surface that we have done. And thanks for listening, and we hope we can take it a lot further. Thanks a lot.